let's look at cube roots. The number c is the cube root of a if c cubed equals a. The cube root of a real number, a, is written as the cube root of a. Some examples of this would be the cube root of 64, which would equal 4 because 4 times 4 times 4 equals 64. Another example would be the cube root of negative 125. This is equal to negative 5 because negative 5 times negative 5 times negative 5 equals negative 125. Now let's look at a function. If we had a cube root function, let's say f of x equals the cube root of x. Go ahead and put a 3 in the index. On the given grid, we're going to give inputs and then calculate the outputs. So I'm going to pick some very obvious choices like a perfect cube, like negative 8, negative 1, 0, 1, and 8, and see what happens. If I take the cube root of negative 8, my input is negative 8 and my output is negative 2. If I take the cube root of negative 1, I get an input of negative 1 and an output of negative 1. If I take the cube root of 0, I get an input of 0 and an output of 0. If I take the cube root of 1, I get an input of 1 and an output of 1. And if I do and calculate the cube root of 8, I get an input of 8 and an output of 2. Let's go ahead and graph these values. At negative 8, I'm at negative 2. At negative 1, I'm at negative 1. At 0, I'm at 0. With an input of 1, I'm at an output of 1. And with an input of 8, I'm at an output of 2. Now let's connect these dots with a smooth continuous curve. Notice with odd roots, you will get smooth continuous values that have domains from negative infinity to infinity and ranges from negative infinity to infinity. This is because for outputs, we will continue to get lower and lower and lower in the y or range values as x becomes more negative. And as x becomes more positive or to the right, the range values increase toward positive infinity. In the real number system, every number has exactly one cube root. The cube root of a positive number is positive, and the cube root of a negative number is negative. An example would be the cube root of 8 gives you positive 2, and the cube root of negative 8 gives you negative 2. And finally, if you have the cube root of x cubed, you will get x. Basically, this is saying that unlike a square root, whatever input sign is will also be the output sign on the range. Let's give this one more example. If I gave you the cube root of negative 125, we know that the output will also have a negative sign on it, because cube roots, signs on the domain, match the signs on the range.